Hello everyone, welcome back to Express Video for All. I hope you all are doing well and feeling confident today. Those who are joining live right now, please type yes in the chat and mention your college name. Let me see how many VTU third semester students are here. So those who are joining live right now, please type yes in the chat and mention your college name. And we are waiting for others to join. Then we will start the quick revision of our DDCO BCS302. So I know many of you woke up early just for this class. 6 a.m. is not easy, I know. That itself shows you are serious about your exams. Am I audible? My voice is clear or not? Please type in your comment. Am I audible? Is my voice is clear? Is the screen is clear? Am I audible? Please comment if I am audible. Write in the comment section. Am I audible? Please type yes in the comment if I am audible. Okay, Samir Alam 2469. Yes, okay. So some of you might be scared of DDCU, I know. Some confused and some just want a clean revision. Don't worry, you are in the right place. So in today's session is a 2-hour quick revision for DDCU BCS 302 special designed for VTU exams. So this is not a normal lecture. This is a revision plus exam strategy plus doubt clearing session. So whatever your doubts is there, you can tell in the live chat. So in this live class, we will focus only on the things that actually matter in the exam. So we will cover important and repeated questions, core concepts you must understand, how to identify questions in the exam, and how to write answer step by step for marks. So very important, we are not doing long theory today. So we are not reading textbook line by line. We are revising smartly because exams are near and time is very limited. So please keep a notebook and pen ready. If you have any doubt, ask it immediately in the live chat. This is a doubt friendly class. Don't think your doubt is silly. If you are confused, many others are also confused. Don't worry about that. Let me tell you one thing honestly, DDCO is a scoring subject. If you understand the logic, you don't need to study everything. You just need to understand what to study and how to write. And that's exactly what we will do today. So if you have any doubt, please comment in the live chat. If this is your first time on Express Video for All, welcome. This channel is only for VTU students, focused revision exam strategy and real help. If you find today's session useful, please like the live and subscribe. It motivates me to do more session like this. So stay till the end of the live. By the end of these 2 hours, you should feel more confident, more clear, and less scared of DDCO. So, alright, enough talking. Let's start the actual revision now. We will begin with the most important DDCO topic, which is very frequently asked in VTU exams. Pen ready, notebook open, let's begin. So, firstly, what I will do, I will from the module 1 I recap that. So firstly we will recap This subject explains how computer works internally, starting from binary numbers to digital circuits. This question is not asked, but the concept is very clear from the beginning. Then you can easily understand the concepts. So what are the topics we will cover here? Digital systems, number systems, conversions, binary arithmetic, complements, signed and unsigned numbers, binary coded decimal and ASCII values, binary logic and K-map. So firstly we will revise this to be clear. So firstly what we will take, digital system. So a digital system is a system that processes information in binary form, 0 and 1. For examples, computer, calculator, mobile phone, these are all known as digital systems. So what will be the key component of these digital systems are registers, store data, logic circuits, process data. So these are the key components. Now we will understand number systems. So a method of representing numbers types like decimal base 10, which implies 0 to 9, and binary whose base is 2, which implies only 0 and 1, and octal means base 8, which are from 0 to 7, and hexadecimals are base 16, in which it covers 0 to 9 and A to F. So, and at last, for example, we can see that for hexadecimal, 25 to the base 10. This is the example of decimal, not hexadecimal. And here 11001 to base 2. So, just two smart were commented. Please tell fixed questions with their solution. So, I will tell it later. Before that, we will understand these basic terms. It takes just 5 minutes, so please wait. I will cover these things. Now we will understand binary codes. Means BCD is just binary coded decimals. So each decimal digit is represented using 4 bits. For example, decimal 9 with binary coded, we can write it as 1001, and the ASCII code is like used to represent characters. For example, A is the ASCII value of capital A, we all know that it is 65, so we can write in binary coded terms like 10000001. At this place we know 2 to the power 0 means 1, and all these value we will take 0, but after that we can count from here. 0 1 2 3 4 5 6 mean 2 to the power 6 is 64, and 64 plus 1 is 65. That's how we can write it as in binary terms. Now we will understand the binary logics. So here we can see that uses binary variables 0, 1 only, and basic operations are and, or, and not. We all know that very well. And also, if you guys have any doubts, you can ask in the comment section. If you have any doubt in any questions, you can freely ask in the live chat. Now we will understand number system conversions. So the conversions can be of 3 types. Means decimal to binary, binary to octal, and binary to hexadecimal. So here I have taken an example of binary to decimal. So it is represented in binary 1010. So I have covered it in decimal form. So 10 to the base 10. The base 10 is decimal, we know, and base 2 is binary. So like that you can convert easily. It is also important for the exam point of view. They can ask for 4 marks to convert this number system to another form. Now we will know binary arithmetic. So binary addition and binary subtraction is there. So we have taken an example for binary addition. So what do you mean by binary arithmetic addition? So here 1 plus 1 is 0, because in the binary terms 1 will be 0. Here the 1 will be going. So 1 here. So again 1 plus 1 is there. Then again 0. So after that again 1 plus 1, so 0, and after that there is 1 carry, so directly we can write it 1. So this is the binary addition. Like that you can do the for the binary subtraction. Now we will understand what it mean by complements. So complement implies invert bits. What do you mean by this? we will understand here with examples. So 2's complement is nothing but 1's complement plus 1. Since we have taken an example here for binary 0 1 0 1. So 1's complement is nothing but wherever the 1 we will write 0 and wherever the 0 we will write 1. So like this, and in 2's complement, since we have converted this to this and we just add plus 1 at the last, means at the right side, then it will becomes 2's complement. Now we will understand signed and unsigned numbers. So here the unsigned numbers, only positive numbers we can take in the unsigned, and signed numbers we can take both positive and negative because they have sign with itself. So their limits of unsigned numbers are 4-bit range 0 to 15. Just do smart work tells, please tell this. What I have to tell? You can type the question directly in the comment section. So I will solve directly for you. And here positive negative is 4-bit range is -8 to +7. And here MSB, most significant bit used as sign bit. So comment your doubt in the comment section. Just do smart work. Now we will understand K-map. This is very interesting and many students feel uncomfortable, and please tell this. Just do smart work. Tell your question in the comment section. I will solve your question and solve your doubts. So comment your doubts in the comment section. So before that, we will know the last topic of our introduction part, which is nothing but K-map. Here is K-map, nothing Karnaugh map. We can known as this name. So it is nothing but a graphical method to simplify Boolean expression. It is used to reduce Boolean expression. In the question given that one Boolean expression and their mean terms. So according to the number of variables, you will draw the squares. So the just do smart work ask dot with an example explain the working of test bench in Verilog. So after this I will explain you what it means. So up to that just wait, I will complete this fast. So where I am, reduce Boolean expressions. So in the question it will be given mean terms, and according to the number of variables given there, you have to minimize that Boolean expression with the help of K-map and minimize logic gates. And also you can use logic gates to implement that minimized expression. Now we will understand the types. So here you can see 2 variable K-map, 3 variable K-map and 4 variable K-map. Here it is nothing but if the 2 variable given, then only 4 boxes will be given, because 2 to the power 2 we only take here. Whatever the number of variables given, you just put 2 to the power 3 means 8, 2 to the power 4 means 16, like that. So here you can see that for 2 variables K-map, 2 to the power 2 4 means a comma b, 2 variables given. So like this you will write 0 1 and at b 0 1. So this is for 2 variable. At the left side here you will write the MSB, most significant bit, and at the right side you will write the LSB, least significant bit. So like that you can understand 1 0 10 means 1 is greater, so it is on 10th position, that's why we write it at left and b at right. Now we understand the second one, which is nothing but 3 variable K-map. So here 3 variables given, so 2 to the power 3 8. So one person commented, explain NAND gate, NOR gate and XOR gate with truth table and timing diagram for 3 input variables A, B and E. So I will just finish this, then tell you all your doubts. So wait for some couple of minutes, I will tell you. and clear your doubts. So where am I? So here, three variables. So A, B, C. We will write A at the left side, MSB, and at the right we will write the LSB, which is nothing but BC. So here you will write the combinations at BC 0001, and here you will write 1 1, not 1 0. 1 1, then 1 0, and 0 1 2 3, like this. 4 5 6 and 7. So like this you have to write. You can learn, or there is some concept behind this, so you forget that, you can directly learn, and how to write you can know. Now at the third part, which is nothing but 4 variable, so 2 to the power 4 is equals to 16, means 16 boxes. So a b c d is there, so a b at the msb and cd at the lsb. Here you will write the combination 000111 and 10, and here 000111 and 10, like that. And in here 0123, up to here you have cleared 4 5 6 7, it is also fine, but after that 6 you will come here, not this row. 8 9 10 11, after that 12 13 14 15, because of these 1 1. Here also, because of that 1 1 comes first, we write 2 at the 10 and 3 at the 1 1. That's the reason behind this. So now we will start the doubt solution class. So so now we will solve the first question, which is asked by Just Smart Work. So the question is, with an example, explain the working of test bench in Verilog. So we will explain the working of a test bench Verilog. So firstly, we will understand a test bench is Verilog is a verification code, not a hardware code. It is used to test whether our design DUT is nothing but design under test is working correctly or not. So important points for exam you can write like test bench has no inputs and no outputs. That's the first point you can write in your examination. And the second one is, it is not synthesized. That's the second point you can write in the examination. Then the third point you can write, it is used only for simulation. These 3 points are the most important points for the test bench Verilog. If you want to know the working of this, I can also explain that. So please comment in the live chat. Just do smart work. Please comment in the live chat. Otherwise, I will move to the next doubt. Please comment your doubts in the live chat. I will explain one by one. This is a quick revision class. Okay, I will explain the working. So listen carefully. So the working of test bench is like, firstly we will declare registers, which is known as reg. So our first step is to declare the register. When I am explaining, I am not writing each word. I will just write the topics or the keyword so you can easily understand. Otherwise it will take lots of time. So our first step is to we declare registers, means to give inputs to the design. And in the second part we will declare wires. So in the second we will declare wires. What are the wires do? It to take outputs from the design. And in the third part we instantiate the main module, means for DUT inside the test bench. So duty is nothing but design under test. I already told you. So like that, inside the test, we will do the test bench to verify. And in the fourth one, we will apply different input combinations using initial block. So after that, we observe output in simulation waveform. That's the working of the test bench. So I can write one more example design for AND gates so you can easily understand that. So here we can see that, for example, with example you can easily understand. The theory part is very easy. For example, you can take AND gate. So for AND gate, firstly we will write module. In any verilog code you should write firstly module. After that you have to write the module name. So here I am writing AND gate like this, and then under the parenthesis you have to write the inputs and outputs. So here I am taking input A, B and Y as an output. So after that you have to declare which term is input and which term is output here. So input I am taking here A comma B. After that what will be the output I am taking, in which we will store data. So output I am taking Y. So here you can see that I will do this one, assign function of Y. In that I am storing A variable and B variable like this. And after that I will end module. As we have started module, then we have to end the module. So we will end module. So now we will test bench for this AND gate. So we will see here. So up to here it is clear or not? Please comment in the live chat. You can comment. Sorry for there is network connection error. Some issue with the network. So now it is corrected. If you have any doubt regarding this example, you can also ask. Now we will know the test bench for this AND gate. Test bench means we will verify. So now we will see the test bench or AND gate. So here we will firstly write module. In module we will write table TB AND gate. So we have written this. After that we will write register A comma B. So here the inputs to DUT. So input to DUT we take like this. Our first step, as I have told you. Then in the step 2, wire of Y. So we are taking wire, means output to output from DUT. So now our first and second step is completed in this one. Then after that we will write, here we have input and out in the register and the output in the wire. Now after that we will initiate the design. This is our third step, as I have told you. And under that, what will be covered? And gate, then dut, then dot a into a, comma dot b into b, comma dot y into y, like that. A, b, and y. With that, we will do this AND gate operation. Then initial begin we will write. So step by step we will understand here in this one. So initially a is equals to 0 and b is equals to 0. So after that hashtag 10 we will write. It is nothing but binary. A is equals to 0, b is equals to 1. After that 10 we again write hashtag 10, then a is equals to 1, all the combinations we will write, and b is equals to 0, then hashtag 10, a is equals to 1 and b is equals to 1, all the combination we have written now. Now what we will do, we will write hashtag 10. I have covered all the four combinations for a and b. Now we will finish. So finish, then we will end this. Initial we have begin, then we have to end also. So we will end, then after that we will end the module. So here we have started the module, so we have to end module. So like this you have to test bench for AND gate. Like this you can give the example. Did you understand this? This is the simple working. Like this you have to do step by step. For any example you can take. Here I am taking the AND gate. So I am giving the overview of this one. Listen carefully. Here initially we have taken register A comma B. It is used to apply input values. Then we have taken wire Y. It is used to observe output. Then again we have used the DUT, which is nothing but instance of the actual design. Then again here in this step, initial block. So applies input one by one. So we have applied input one by one. Then hashtag 10 is nothing but delay between inputs. It indicates delay between these inputs. All the combination we have to write. Then again this. And here at the final we have dollar $finish to stop simulation. So this is the whole working of test bench for AND gate. So how test bench works we have no. So the test bench gives different input combination to the design and checks whether the output matches the expected result using simulation. So one line exam answer you can write like, a test bench is a Verilog module used to verify the functionality of a design by applying test inputs and observing outputs through simulation. So that's the simple working and explanation. So just do smart work. If you guys have any doubt, you can comment in the live chat. This is a live class in which you have to ask your doubts and I will solve that. I will clear all the doubts. So here just now we have covered the test bench for AND gate. So just do smart work. Did you understand the topic? Now the next person ask Chinmaisi, sorry for the pronunciation. So explain NAND gate, NOR gate and XOR gate with truth table and timing diagram for 3 input variable A, B, C respectively. So now we will know this one. Now we are moving towards next doubt. So now we understand the NAND gate first. So NAND gate. I already uh, making this video separately on this topic, so you also can watch it later. So here I am definition of NAND gate is nothing but a NAND gate is the complement of AND gate. It is a very simple definition. The output is low only when all inputs are high. So for Boolean expression we can represent it as Boolean expression. AND gate, you know na, in AND gate it is multiplication. So for Boolean expression for NAND gate will becomes y is an output in which a dot b dot c to the whole bar. So this bar is nothing but making this whole thing not. So like this you can explain. So I can also simplify this. It will becomes a bar plus b bar plus c bar, like this. So this is the whole thing the NAND gate do. So now we will discuss the truth table for NAND gate. So total 2 to the power 3 means 8. 8 combinations will be here. So the simple way is writing 0 0 0 0 1 1 1 1. Then after that 0 0 1 1 0 0 1 1. After that 0 1 0 1 0 1 and 0 1. So like this you can write the combinations for 3 variables. After that only when all the input variables are 0, then only it is true. Sorry, it's when all the variables are 1 means true, then only it will be 0 means false, otherwise it will be true. So here you can see that if it is a variable is 0, so a bar is 1, so plus is nothing but or. So if any one value is true, it will give the true value. That's why here when all the values are 1, then the whole bar will becomes 0, this will 0 0 0, then only it will be false. That's why like this 1 1 1 1 1 1 and at the last it will be 0. So this is the simple truth table for the NAND gate, so you can easily understand it. So any doubts in this NAND gate, truth table and Boolean expression? So Samir Alam 2469 written clear, sir. Okay, now we will move to next part of this question, which is nothing but NOR gate. So NOR gate is asked by one person. So if you have any doubts, you can also comment in the live chat of your question directly. I will solve that for you only. So now we will see NOR gate. So the definition of NOR gate, we can say that a NOR gate is the complement of OR gate. As here we can see that NAND gate is nothing but complement of AND gate. Like that, this is complement of OR gate. So for Boolean expression, we can write like Boolean expression for this is nothing but y is equals to a plus b plus c to the whole bar. So after applying this, it will becomes y is equals to a bar into b bar into c bar, like this. So now we will understand the truth table for this. So like this, 3 variables we will take here. So truth table for this NOR gate. So simple way for writing the combinations I have told. Now again I am telling you. Firstly you will write the left side 4 zeros 0 0 0 0. Then 4 ones 1 1 1 1. Then you will write 2 0 2 1 2 0 2 1. After that 1 0 1 0 1 0 1 0 1, like this. Now we will decide the output for this. So what are the outputs? So here you can see that output is 1 only when all inputs are 0. It is totally contrast of this NAND gate. Here when both all the inputs are 1, then it is 0. Here when all the inputs are 0, then it will be, when all the inputs are 1, then it will be 0. Otherwise, here the output is 1 only when all inputs are 0. So here it will be 1, and for all rest of the things it will be 0. So like this. So have you any doubt in this truth table for NAND gate and NOR gate? If you don't have any doubt, we will move towards XOR gate. After that, one person, Shubham Patil, asked explain thermos. If you have any doubt, you can ask in the comment section. You can directly write the question in which you have facing doubts. So I can directly clear that question only. So if you have any doubt, this is an interactive class. So you can write your questions in the comment section. This is a quick revision class. If you are facing any doubts, you can easily comment in the live chat. So I will clear that. This is not a proper lecture class. This is a doubt clearance class. One tip for you is that when you are solving the problem, oh, so one person asked, can you say the questions of module 5? So in module 5, I already made one important video. In that, I have explained what are the important questions asked. So one person asked, Mr. Comment 49, only explain important fixed questions for today exam. Okay. So the fixed questions are like 4 raised to 8 multiplexer, 8 raised to 1 decoder. So like that. So you want that only? If you want that, comment yes. One person asked f of x comma y comma z, where x dash y plus y z dash plus y z dash. So we can also solve that. For 3 variables you have given. So just now I have completed NAND gate, Boolean expression and truth table for it, and NOR gate, Boolean expression and truth table. If you have any doubt regarding this is also very important. You don't have to miss these questions. So if you have any doubt, you can directly question in the live chat. So the given Boolean function I will solve now. So group common like this. So step by step we will solve. Vy bhav 444. So now I will solve. So now we will see. If you like the video, please subscribe our channel and like our live chat. So now we are going to solve the Boolean function given by one of your students, Vaibhav 4444. So the question is, the variables given here is total 3 variables, x, y and z, and the given equation we can see x. So the given equation is nothing but x dash y plus y z dash plus y dash z dash. So step by step we will see here. So our step 1 is to group common terms in the Boolean algebra. Look at the last 2 terms here. So Here we will grouping this. So we can take z dash here common, because in both the terms it is there. So we are take z dash common. So the equation becomes like this is nothing but z dash and then y dash plus y. This will become, and we also know that y plus y dash is nothing but 1. So y z dash plus y dash z dash is equals to z dash. So this is clear. This is our step 1. Now in the step 2 we will substitute it back in this equation. So up to here we have know the value of this one, which is nothing but z dash. So we substitute in this equation. In the initial equation we will get f is equals to x dash y plus z dash. So up to here it is clear. Now in the step 3, in the step 1, this is step 2 and this is step 3. So in the step 3 what we will do? We will final simplified expression, which is nothing but f is equals to, we will write like this, z dash plus x dash y. Why we have written this? Because this is the simple form we can make. So sum of product form already is there. This is in the sum of product. Sum of product means here it is in sum form and in between two expression it is plus. That why it is known as sum of product. So how to write in VTU exam? It is very important. So how to write in exam? So you can say that steps to write. Firstly, what we have done? Write given expression here. Whatever the expression given, we have written that. After that, take common terms. So after here, we can directly see that z dash is common. That's why we have taken common. Then use identity is y plus y dash is equals to 1. Then after putting this z value in the expression, we get this f is equals to x dash y plus z dash. So we have written the right final simplified result. So like this you have to write in your examination. So the equations will be like this, x y z for this z dash plus x dash y. This is our final answer. So like this you have to solve. This can be asked for 2 to 4 marks. This is very simple, but they can ask more questions on this. So now Vaibhav 444, the doubt is clear or not? Any other? So Vaibhav, the doubt is clear or not? Samir Alam 2469, love you sir. Love you too, bro. Now the mottos key. 4 types of operation to be performed by instructions computer. Explain the basic type of instruction formats to carry out C. So there is the given the expression a plus b. I already make a separate video on this question only. You guys can go through that, or else I can tell you right now. Draw the K map for that. So for that we have to draw the K map. You are telling na? Okay. Any other doubt? If it's there, you can comment in the live chat. So if you have any doubt, you can tell me in the comment section. So now we will draw the K map for this. So our step 1 is to convert this into min terms. So by min terms we only make the K map, then minimize it, as we know. So our step 1 is nothing but convert into min terms. Convert into minterms. The expression given here, we will convert that into minterms. So our first one is x dash y. So here z can be 0 or 1. As we know that the possibility is like that. So z can be 0 or 1. So we can write like x dash y in bracket z plus z dash, which is equals to x dash y z plus x dash y z dash. So the minterms for this will becomes minterms. We can say that x dash is it means 0 1 1, which is nothing but 0 1 1 is m3 at m3. 2 to the power 0 is 1 and 2 to the power 2 is 2. 2 plus 1 is m3. Like that, it is for 0 1 0. So it is m2. As I have just written this one, x dash y z and x dash y z dash. That's the thing. Now we have converted x dash y in minterms. Now we will do same for others. So in the second, we will convert this a y z dash, and here x can be 0 or 1 like z in the step 1. So the equation will be like x plus x dash y z dash is equals to x y z dash plus x dash y z dash. So minterms will be like here in the same format. We will do for x y z dash, it will be m6, and one more thing, x dash y z dash, it is already known, m2. So we can again write or else we can leave. So now we will do the same for the third equation. So this is first, second, now we will do the third. So the third one is nothing but y dash z dash. X can be 0 or 1 here also. So x can be 0 or 1. So the again we will take like this equation. So up to here, did you understand? Up to here, did you understand or not? These two steps, how we have converted this into minterms. Like that we will do here. So here we can write y dash z dash into x plus y x plus x dash. So it will becomes y dash x plus x into y dash z dash plus x dash y dash and z dash. So the minterms will be like here, minterms will be x y dash z dash, it will becomes m4, and for here it will be x dash y dash z dash, it means nothing but m0. So we will write the minterms separately. So up to here it is clear or not? This is very important and easy question they can ask. Here it is clear. Vamshi GM, up to here it is completed. Explain DMA and bus arbitration techniques. On this topic, I have already created one separate video at how DMA works, what are bus arbitration techniques. So you can check out my playlist. Or else I can explain you if you want. Please comment. You can ask the numericals also here. I will explain that. Up to here it is understand or not? Did you understand this? So here I will explain this. First, Webov 444. Did you clear this one? Understand these points or not? So after that we don't do anything. We will take this min terms, then directly applying to the K map. Then we will group, then directly we will minimize that. So it is very easy. So you can do by yourself, or otherwise I will do. Please comment in the live chat. So the next question is, explain DMA bus arbitration techniques by Giggle Godfather. So this question is asked by Giggle. So firstly you will understand what it means by direct memory access, means DMA. So DMA is nothing but it is a technique in which an input output device transfers data directly to or from main memory without continuous involvement of the CPU. That's the basic definition of a DMA. Up to here it is clear or not? So this is the definition of DMA. Up to here it is clear or not? Godfather. Okay, now I am moving forward. CPU is free to do other work in DMA. We know. So why DMA is needed? We have to write these points. In normal input output, CPU controls every data transfer. We know any operation is held in a computer, it is controlled by CPU. So CPU becomes very busy. So for this, difficulty of CPU is very busy, otherwise it will going to hit. So we have to slow for large data transfer. So DMA solves this problem, the problem facing by the CPU. Then it got heated, then it can be anything. So the block diagram, so the block diagram will be like, so explain addressing modes. So yes, so if you want, I can also explain the working of DMA. So Giggle, did you want that? So the block diagram is like, you will write the CPU, then the main memory, input output devices, then the DMA controller, like that. I already explained very well in my videos. You can go and check out my playlist. So now we will know the working of DMA step by step. So firstly, the CPU initializes DMA by giving three things. Firstly, starting memory address, then number of bytes, then direction, means read or write, it should read or write, like that. And in the second one, DMA controller request control of system bus from CPU. Then CPU grants the bus and becomes idle. The CPU becomes the idle after giving the control to the bus, grants the bus. So then the DMA controller transfer data directly between input output device and memory. So after transfer completion, DMA sends interrupt to CPU. So that's the simple working of DMA. So it is clear? Giggle Godfather, what you have said no for? You want more explanation or what? Okay, up to here you have completed. So one more thing you have to write. Advantages of DMA. If you write these points, then it will be beneficiary for you. So the advantages of DMA is like faster data transfer, CPU utilization improves, and then the efficient for large data blocks. So one line exam answer you can write in the booklet. DMA allows input output devices to transfer data directly to memory without continuous CPU inventions. That's the simple and neat and clean definition for the DMA. So CPU inventions means it work like CPU, it gives rest, intervention. So like that. So now we will understand bus arbitration. Up to here, DMA, did you understand the topic or not? Giggle, up to here. Sir, go to 3, 4, 5 modules. So you can ask any question from 3, 4 and 5 modules. I will explain it very well so your doubts will be clear. If you have any doubt in any of the question, I already uploaded the most important questions notes on my channel. You also can go through that. From there you can easily pass and score good marks if you have completed all the questions which I have told in that video. So you explain the important question. Okay, you want that question to be explained. Okay. Firstly, I will ask for giggle. Is it clear what I have explained up to this? Giggle up to here is it is clear or not? So one of my the Gani asked explain addressing mode. So we can easily understand addressing mode. If you guys have any doubt, you can ask in the comment section. So now I will explain what it means by addressing modes. So an addressing mode specifies how the operand means data is accessed for an instruction. In simple words, you can write in your examination like it tells how if you guys have any doubt, you can ask in the comment section. Now I am explaining the addressing modes. So in it tells this the addressing mode is nothing but it tells the CPU where the data is and how to get it. This is the simple definition. Why addressing modes are needed? This question is asked many times. So the direct addressing mode and the third one is indirect addressing mode. So there are no one more thing is there, register addressing mode and register indirect addressing mode and indexed addressing mode and relative addressing mode. So after one by one we will understand each. So addressing mode are very important for the exam point of view. So one by one we will explain each. Did you want the explanation of each addressing mode or not? DMA. I already explained this topic. So once again, I will explain for you. So DMA, many students ask. So DMA is an scoring. This is very important question. You guys are correct. So listen carefully. DMA is nothing but direct memory access. So what it means? So DMA is a technique in which an input output transfers data directly to or from main memory without continuous involvement of the CPU. Up to here it is very simple and easy definition of DMA. So CPU is free to do other works by this DMA. So why DMA is needed? We have to write this. In normal input output, CPU controls every data transfer. We know that, and CPU becomes busy. That's why we use DMA, and because of that, slow for large data transfer. the transformation of data will be very slow. So that's why we use DMA to solve these problems. So the block diagram for DMA is like you will write CPU, then the main memory, input output devices, then the DMA controller, like that. I already make one separate video of for DMA. So did you want working of DMA or not? Please comment. I will explain the working of DMA. So now we understand the works, and the third one is direction, means it have to read or write. This is our first step. In the second step, DMA controller request control of system bus from CPU. It will take the control from the DMA, from the CPU to DMA. Like in third step, CPU grants the bus and becomes idle. Here, after giving the control to DMA, CPU becomes idle in the third step. Now, in the fourth step, DMA controller transfers data directly between input-output device and memory. And in the last stage, after transfer completion, means the data is transferred to the memory or wherever it have to transfer. DMA sends interrupt to CPU. That's the simple working of DMA. You can write in your examination to get the full marks. So it is clear or not? If you have any doubt, you can ask in the comment section. I will solve your doubts. Up to here it is clear or not? Varsha SK, Mohammed Zain. Up to here it is clear or not? Working of DMA, what it means by DMA, why it is needed. Sorry. Up to here it is clear or not? If you guys have any doubt, you can ask in the live chat. If you guys have any doubt, you can ask in the comment section. So add R3, R1. This is very important question you asked here. I have already created one separate video on this only. So you can check out that. By that you can easily score full marks. In that way I have created. So you can check out my playlist. सर आपके इम्पोर्टेंट क्वेश्चंस पढ़ने से कितने मार्क्स स्कोर हो सकते हैं? सो द वीडियो पैटर्न कैन बी चेंज, बट the scoring will be like, if they ask like very typical questions, so if your basics are clear, your concepts are clear, you can easily score 60 to 70% above. So if you have done little bit from here, you don't understand the concept, you will not get the full marks. So like that you will score. So up to here, if you have any doubt, you can ask in the comment section. This live class is only for the clearation of doubt. So if you have any doubt, you can ask in the comment section directly. One important question is there from module 2. I can tell you guys. So explain the working of 4-bit adders using 4 full adders. So here what you have to do, firstly you have to write the diagram. So in the diagram you will write 4 full adders. Like this you will write the 4 full adder. There is nothing but C naught. This is the incoming input. Then here S naught is nothing but sum. After adding A naught, B naught, the sum is here. So after sum, whatever the carry will be there, it will going to the full adder 2, second full adder. So C1 like this will be the diagram. So you can see A1 B1, A2 B2, A3 B3. This question is very important for the exam point of view. I already explained very well this question in my videos. You can check out my playlist. So if you guys have any doubt, you can ask in the comment section. I will solve your doubts. And if you are coming first time at my channel, you can subscribe. Express video for all. So you guys have any doubt? If you guys have any doubt, you can ask freely. Here I am to solve your doubts. One more question is there. This one. Design a BCD to access 3 code converter. So in simple words, I am telling here, whatever I have did is nothing but this is zero value in binary forms. So how you have write in binary? 0 0 0 0. So here it is nothing but 1. So 2 to the power 0. So wherever the 1, so we have to put the that in power 2. So here's the ones place. So to the power 0 means 1. So I have created like this. So 1 2 3 4 5 6 7 8 9, up to 9 I have written. So now here output access 3 code. So here what you understand by access 3 code, it is nothing but we already started from the third. So this is 3. So here you can see that 0 1 2 3. From here we have started w x y z. So we have to add like this. So here what I have done, this is 3 4 5 6 7 8 9 10 11 12. Like this I have written for BCD to access 3 code converter. So after that, wherever the z is 1, I have created one separate K-map for every variables for z, y, x, w. So wherever the combination for 0 0 0 0, it is 1 z. So I have created like it mark 1. So 1 wherever the 1, so I have marked at 1 for the K-map. So like that I have done. So here you can see that there's group I am minimizing this. So I will get z value is equals to d dash, y value is cd plus c dash d dash, x value is nothing but b c dash d dash plus b dash d plus b dash c after minimizing, and w value is nothing but bc plus ab plus a. So after I am getting this, you can also simplify this and take common, and directly you can, or else you can directly convert this into using simple AND gates, OR gates, NOT gates, implement these equations. So this is for Z, Y, X and W I have done here. You can see that. So if you guys have any doubt, I can solve. You can comment your doubts in the live chat. This class is only for doubt clearation. If you guys have any doubt, I will solve that in any types. If you want to know any working, if you want to know any numericals like that. So if you guys have any doubt, you can freely ask in the live chat. If you guys have any doubt, you can ask in the comment section. If you guys have any doubts, you can ask freely in the live chat. The doubt can be numerical based, theoretical based, differentiation, like that. You can freely ask in the live chat. And if you are coming first time at our channel, please subscribe Express Video for All and like our videos. And also we have uploaded all these notes at our Telegram channel. Link is in the description, or you can join from our channel. There is our Telegram link. So BCD to access 3. So okay, this is only BCD to access 3 I have explained. Once again I can explain for you. So here the question will be like, design a binary coded decimal to access 3 code converter. So firstly we will understand a BCD digit can be converted to its corresponding access 3 code by simply adding 3 to it. Means that we have written here, this is nothing but 0 1 2 3 4 5 6 7 8 9 in binary terms. So as you know that wherever the 1, so to the power 0 means 1, so this is nothing but 1 written in the binary form. This is nothing but 2 to the power 1, so it is 2. So this is nothing but binary coded decimal value of 2. So like that up to 9 we have written. So what it means by output access 3 code, it is nothing but we have taken 4 variables w, x, y, z, and we have started from 3 only. So you can see that from here 0 1 2 3, so we directly started from here. That's the thing we have written here. So since we have only 10 digits 0 to 9 in decimal, so we don't care about the rest and mark them with a cross. Means after 9 in the K map we will mark X, don't care values. For 10, 11, 12, 13, 14 and 15 we will mark don't care. As you know that don't care values are those we only use to make the form of group to the maximum number of elements, or else we don't have any inputs to make the group, so we only use don't care values at that time. So up to here it is clear or not what it means, what we have done here? So Mitra Gali, up to here it is correct. Should I further proceed? If you want, I can explain. Up to here it is clear? Yes sir. Okay, now I will explain rest of the thing. So in the rest of the things what happens is nothing but here we can see w, x, y, z. So for 0 0 0 0 combination only y and z value is 1 1. So I have drawn one separate k map for each with the input symbols a b c d, a b c d here also and here also. So this is for z, this is for y, this is for x, and this is for w. Like that you have created. Now you have to see here for the combination 0 0 0 0 it is 1 for y. So at the y we can come for 0 0 0 0 it is 1. So I have marked this as 1, or directly you can see that this value is nothing but 0 0 1 2 3 and directly min terms as we have written 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So directly from seeing here you can mark this as 1, and rest of the values from 10 11 12 13 14 and 15 we have marked it as don't care. We only use when it is much needed to form a group. So up to here it is clear. I want your support to further proceed. It is clear or not? Okay. Now what I have do here, I marked what are the points are true for that combination. So 1 1 1, then making the groups. So what is the maximum number of groups? Here we can make the number of groups for 16, 8, 4, 2 and 1 only. So like this we only group. We cannot make the group of 3, 5, 7 like this. So we only have to make the group of 2 to the power, means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. 4 variables, so up to 16 it is here. So like that we have to grouping Then after grouping we have to minimize, since we have taken this group, say first group for this, so here it is covering whole row, so it definitely will change, so we have not taken anything from AB. So now we will check at 0 0 and 1 0. Why we have checking from 1 0 0 and 1 0? Because the group is covering only this column, that's why we only check. And we will take only those variables which have same value, means for C D, for C it is 0, for here it is 1, it is changing. So at D 0 it is 0, so we only take D. So D is D dash because it is 0, otherwise we will take it as 1. Up to here it is clear or not? This concept is very important. Most of the students confused why we have to take D dash, why we have to take D, and when where we have to check, why we have taken not these AB, like that. If you have any doubt in these K maps solving problems, I can easily tell you how to solve, then you will get easily full marks. So comment if you want the special how we have minimized this K map and how we get this expression for X, Y, Z and W. If you want, please comment yes. Need 3 module. Okay, you guys can mention the module so I can easily tell you how to solve that. So need 3 module. Okay, I already separated one video. In that I have mentioned all the important questions which may asked in VTU examination. Sir, module 1 important question revision please. So it already is there on my playlist, you guys can check out. And if you have any doubt in any question, so you can ask here. It is very important to clear your doubts before going to examination. This is very difficult, not difficult but tricky questions they can ask. You just have to use the logic and solve it. Yet it is nothing but the BCD is simple, but the minimization, how to minimize, when we have to take the X and how we have to group, you have to think logically. So that's the main thing you have to do in DDCO. So here Z is equals to D dash, Y is equals to CD plus C dash D dash, like that we will get after minimizing this K map. And then what we have done, by using logic gates we have implemented these equations. It's simple. Or else you can these equations can be minimized by taking D dash here, like B dash is common, then you have to one time add that one, or else you can directly implement logic gates. So this is the 10 marks question, they can ask many times. So you guys can comment your doubts in the comment section. Whatever question you are facing problem, I will solve that. Okay, okay, Mahendra Yemantri. Implement y, a, comma b, comma c, comma d, whose midterms are 0, 1, 6, 7, 8, 9, 10, like this, using 16 to 1 multiplexer and 8 to 1 multiplexer. This exact question I already done in my playlist. So you can directly go there, and if you have any doubt in any step, so you can ask here. I am here up to 8 o'clock. So if you guys have any doubt in any step, so you can directly mention. So this exact question I already done, so there is no point. So again I will tell. So if you guys have any doubt in any step, you directly mention that, so I will solve, because it takes lots of time. There are more members, so they have to uh, question that. So if you guys have any doubt, you can comment. in module 3, in which question you have doubt, you directly mention that. So I will just clarify that. So one of the student asked one question. So this is also very important question. These types of questions can be asked. So, sir, module, sir, passing marks. So I already uploaded the passing package for all the modules. So what you have to do is nothing but prepare well and revise. Revision is very important in this DDCO. So pipeline answer please. So pipeline I already explained. I explained very well in my videos in which I have explained in detail. It is very lengthy and easy concept. So you can check out my playlist. It is there. Pipeline answer, sir. Sir, module 1, any important question? Explain. Sir, in if you want any important question, you can directly mention which important question you want. So in one person asked, x is equals to a plus not plus a into b plus c into d. So we have to implement by 3 address instruction format, 2 address, like that. They have asked. Now, so what we have to do in this? The format will be like, we have to write firstly destination, source 1 and the source 2 in 3 address instruction format. So here what it means, 3 address, one is for destination, second is for source 1 and third is for source 2. So the execution steps like m1 is equals to a into b, m2 is equals to c into d, then x is equals to m1 plus m2. So these are the execution steps for that one. So the instructions will be like we use in CSS. So MUL is nothing but multiplication M1 comma A comma B as you have provided. Then MUL multiplication M2 comma C comma D. Then add X comma M1 comma M2. These are the instructions that how you can do. So the characteristics like least number of instruction used, faster execution, more registers required. So 3 address instruction format, did you clear? It is clear or not? So like that you can explain. Those who are asking for passing package, I already uploaded that video. Yes, the passing marks is 36. Yes, you are right. Means out of 15 you want 18 marks. Out of 15, 50. So you don't have to think about the passing. You have to think about how to score good marks. That should be the mentality. Then only you will get good marks because you have to maintain the CGPA. This is 4 credit subject. So Hiteshan, did you clear 3 address? 3 address instruction is clear or not? Is the rest 367? Is that clear or not? If you want any question to solve, or if you have any doubt, you can directly ask me how to solve, how to answer. So please tell me which question you want to solve, or which question you want to be clear. So if you have any doubt, you can directly comment in the live chat. You can directly post the questions. You guys can take your 5 minutes break, so you can collect your doubts, so I will come and solve your doubts. So 5 to 10 minutes you can easily take, so I will be here only to solve your doubts. So you guys can go and collect your doubts and come. Uh, so guys, uh, did you have any doubts? If you have any doubt, I will clear that. So if you don't have, these two most important questions which you don't have to skip. So the questions is like this one. What is multiplexer? Explain 4 raised to 1 multiplexer with a neat diagram. So firstly you have to repeatedly learn the definitions which is very important, like multiplexers, decoders. These definitions which must to learn before going to exams. So there is very simple and easy definition. A multiplexer or mux, a multiplexer can be written is like mux is a combinational circuit with more than one input lines, one output lines, and more than one selection lines. This is a simple definition of multiplexer. You can easily write this in your examination. So now we will know each of the 4 input I0 through I3 is applied to one input of AND gate. So here I will explain this diagram. So selection lines S1 and S0 are decoded to select. Pipeline question I already told you in very detail. You can check out my playlist. If you again don't understand that, then you can directly comment there. I will make a separate video for that. So here selection lines S1 and S0 are decoded to select a particular AND gate. The output of the AND gate are applied to a single OR gate that provides the one line output. So basically I am explaining this. Here I0, I1, I2, I3 is there, and two select lines S1 and S0. One is connected with NOT and one is directly S1, and this is S0 negation and it's not simple. So what it's done here, if you know this truth table, I will remove this. So if you know this truth table, you can easily draw this one, and this is simple 4 is to 1 multiplexer representation where I0, I1, I2, and here S1 and S0 select lines and Y is an output. So here what it done in the diagram. So with that truth table you can see S1,